Welcome friends to our new video. In this video we are going to learn how to use a board viewer. Now last video we learned how to read the schematic diagram, how to check the signal and how to read the diagram, and from that diagram how can we diagnose the problem. Now in the newer motherboard the location numbers are not given on the motherboard, like the location number for the resistor or the capacitor or the chips or the diode or anything like a MOSFET. Nothing is there. Board is most of the plain. So but nowadays the good thing is that they use a board viewer. So from using the board viewer it's very easy to locate the component and their connectivity. So in this sections we are going to learn how to use a board viewer, their connectivity, their test point. So everything we'll learn in this section. For that we have to use a FlexBV application. Like in Acrobat Reader is used to read the PDF file. So similarly the FlexBV application is very useful to read the board viewer file. So what I'll do is I'll use a FlexBV application. So here is my FlexBV application. I open this application and now I open that particular file for this model. So this is my model. This is a Compal LA G801 and this is my schematic diagram. So for the same schematic diagram, this diagram in the PDF format. So I'll download this, already I download this Compal LA G801 board viewer. So I'll go to the downloads and here is my BRD file. So the board viewer file extension either BRD or BDV or CAD, something like that. So this file extension is BRD. Here mention the BRD. So this is my board viewer. This is on the front side where the CPU is there. So this is the CPU side, this one is a CPU. Then here is a RAM and these are different connections, and this is the back side, and this is onboard RAM. Here is a SIO. So the different components, locations and their connectivity, everything is given. Suppose like if I zoom this, then it will show all the connection, like the CPU, it will show me the connection where they are connected and all things are given here. Okay. So what we'll do is we'll start from scratch. Like we start from battery charging section and we first see where is my current sensing resistor is, and for that first of what I'll do is I'll go to the schematic diagram and I'll just see where is my current sensing resistor, location number, and then I'll come back to the board viewer and I'll just find where is the exact location of the current sensing resistor. Okay, so I'll come here at the board viewer and I'll see this is a page number 84 and this one so this one is my current sensing resistor. It's called PRB3. The location number is PRB3 and the value of this resistor is 0.01 ohm. So here it should be the 19 volts should come across this two MOSFET, because here are the two MOSFET, right? So what we'll do is we'll go to the board viewer and type PRB3. We'll come here, Control F, then find, then I'll type here PRB3. Okay, then select, then search. That's all. Now this resistor is here. You can see this resistor here. This one is a PRB3. So if I connect here, then it will show me the connectivity. Like if I connect here, then here should come a 19 volt. You can see here it's mentioned PRB3 4, then plus 19 volt. Then this one is output. Okay, so it's mentioned like that. So here your 19 volts supposed to come. If the 19 volt not coming here, then you have to go back, MOSFET number PQB4 and PQB3. Here are PQB4 and PQB3. So here are PQB4. This point is connected to the MOSFET drain, and then source is connected to this, and their drain is connected to the connectors, like that. Connection is like that. That means the supply coming through here, then coming to here, then connect to here, and then going to this resistor, and from that resistor output is going to the entire motherboard. See, it's going on so many points, all the buck converter on the both the side. This voltage is going everywhere. Most of the side is going everywhere. So you have to check here a 19 volt, right? Now at that gate, if it is not coming here, then you have to, what you have to do, you have to check at pin gate, the gate voltage. Okay, it's like that. So next thing is, if voltage is coming here, then what you have to do is you have to go the next section, that is a 3 volt and 5 volt section. So this is a 3 volt and 5 volt section, and I should get here a 3 VLP voltage, and here the chip location is a PU301. Can you see here? Here PU301. So to find where is a PU301 exactly is, so what I have to do is I have to go to board viewer and then Control F, then here I have to type PU301. Okay, yeah, PU301, then select and search. Now the chip is here, here is the SIO, so the chip is here. Now everything is, see, when the chips is located here, that yellow highlights, then there all the pin information are given on the right hand side. This totally is a 21 pin chip, and all pinouts descriptions are given on the right hand side. Okay, so the input pin is pin number 2, 3, 4, like that. So these are the input pin. Okay, so this one is the input pin number 2, then 3, then 4. So here you have to check that 19 volts supposed to come. And one very good thing is here, because this chip is so small in size, so you have to be very careful when you are touching the pin by multimeter. But the good thing is, using a board viewer, you will come to know the connectivity from the chips to the other component. Say something like these are the pin you have to check here, but if you can't able to check at this point, then you can check at this, you can check it this coil also, this PL301, or you can check this capacitor also, PC305, or this capacitor PC306, or PC304, or PC301. Any point you can check which is convenient to you, right? So here it should come a 19 volt. Then the output voltage is a 3 VLP. So this 3 VLP is where? Here pin number 16 and pin number 17. So we'll find where is the pin number 16 and 17 here. You can see here pin number 16 and pin number 17 is even mentioned also here, pin 16, 3 VLP. So click here and then you will find the connectivity to this pin. Then you can check this 3 voltage at here. If you can't check here, then you can check here, because this point is a big point. So you can simply check here. Here should come a 3 volt. If it is not coming here a 3 volt, then what you have to do is you have to check LDO enable. Where is the LDO enable is? LDO enable here. You can see in the schematic diagram also. Here LDO enable this pin. So if this voltage is not coming and this voltage is coming and this output is not coming, then you have to check the enable pin number 11. So where is the pin number 11 is? Pin number 11 is here, this one, LDO enable. So you check here LDO enable. LDO enable should be given to the 3 volt to the pin number if not 11, coming here. It's called the LDO enable. Resistor. Simply you have to follow the steps like that. Okay. Now, so in this way, 3 volt is coming, check if the 3 volt is not coming here at pin number 16 here and 17. Here is a resistor in series. 16 and 17. This resistor may be open. Voltage is going. It's going to the different part. So this resistor going to the different part. So you have to check that. There is a 19 volt is coming and 19 volt is on the SIO where this voltage is coming. This thing for that reduced by this resistor. We'll go to the SIO page first. Okay, this one is SIO. Okay, this one is SIO, and that 3 VLP voltage is coming here, pass via this resistor. The resistor location is a PR, R3986, and this the value of this resistor is 0. So there may be not resistor also. There is a short pad is there. So 3 volt is passing via this resistor, passing to this here, and it's going to the pin number 22, 33, 96 or 111. So we have to go back to the board viewer and we have to check 111. Where is 111 is? Here. Here. This pin. When you click at particular this pin, then this will show all the connectivity. So this 3 volt, either you can check pin number 33, you can check pin number 22, either you can check this capacitor, or you can check this resistor, or you can check this resistor. Any of this point you can check this 3 volt which is coming to the SIO. So SIO should get this 3 volt. Okay. Now the next signal is EC reset. So what you have to do is, now you can in this board viewer you can find straight away signal also, not the voltage but also the signal. So how to find the signal? Simply Control F, then type here EC underscore RST. Simple. Click here, then search, then it will show here. Come to the SIO and check pin number 37. See, it's called ECRST pin number 37. So you have to check your 3 volt, right? Now the next signal is what? On off button or the power button. So find where is the power button. You can find like from here also. Here also. These are the RSM RSTs. All signals are here. This is a lead switch, EC on. These are the power button out. Then these are the on off button. So come here. This is the on off button. On off button pin number 114. So you can connect multimeter here. Press the power button. At that time you should get a 0 volt. First it will come a 3 volt. But as soon as you press the power button, it goes to 0. And when you release the power button, it come back to 3. That means at pin number 114, you will get a 303 variation signal, and this voltage is coming. That means the input triggering is perfect, right? So similarly you have to trace the signal. Then what you have to check is next signal is EC on. So Control F, type EC on here. This one signal, select it, search it, go to the pin number 114. This one is EC on. So as soon as you press the power button, at that time SIO will generate this EC on signal. EC on signal trigger all this buck converter output, and all the buck converter start functioning, right? So similarly in this board viewer you can find any signal. Like suppose if you want to find a RSM RST, Control F, RSM RST here, select it, search it. This RSM RST signal generate by this SIO, and where is going? It's going to the CPU. So is the CPU, and this one is the SIO. So this pin number 100 generate this RSM RST signal, and the red line is going. Where this red line is going? This red line is going to the CPU. Where, in which pin it's going? It was straightway is shown here. It's going this side. Okay, so in this way you can check here. See RSM RST here, pin number 1251 EC RSM RST on the CPU. This signal you can't check directly on the CPU, but you can check RSM RST either here, this test point is also given, or you can check on the SIO, pin number 100. So similarly, if you want to check SLP3, SLP4, then what you have to do? Control F, type PM underscore SLP S3. You can simultaneously check multiple signal also. I'll type here PM underscore SLP underscore S4, okay, and SLP underscore S5. See, all three signal I taken here, SLP S3, SLP S4 and SLP S5. Then search, all signals are given. See, all signals are, this signal is generated by the CPU. You can check anywhere this signal. You can check individual signal on SIO. You can manually also check. Here SLP not mentioned here, but it must be there. So in this way you can check all the signal. Like if you want to check particular VR on section, so go Control F, type VR underscore on, search it like this, like this. Now which pin generate VR on signal? Pin number 121. So like that. So in this way you can check all the signal. You can check all the buck converter also. Like if you want to check particular buck converters, we'll go to the 3 volt and 5 volt sections. So now this 3 volt and 5 volts, this is a RAM supply. Suppose this is a RAM supply. And if I want to, if the 1.2 volt is not coming, this is a 1.2 volt buck converter, and the 1.2 volt coming across these capacitors and generated by this buck converter. Suppose if this voltage is not coming across this capacitor, and if I want to check why this is not coming, then for that I have to see this chip. So location of the chip is PUM1. So I'll come here, Control F, PUM1, search it, select it. So this is a PUM1. I'll zoom it, this PUM1. And now if I want to check all the inputs and output, then you can straight away, all the things are mentioned here also. But if you want to take a reference by schematic diagram, then come here, check where the input supply, 5 volt, pin number 11 and 12. You should get a 5 volt, 11 and 12. Come here, search where is the 11 and 12. These are the 11 and 12. So you can check the 5 volt here. You can, if 5 volt should come here, okay. This VDD or VDDP, okay. And then these chips require what? These chips require enable signal, that is SysOn. And this SysOn signal, who sent this SysOn signal? This SysOn signal sent by SIO to this RAM converter chips. So in which pin it is coming? It's coming by on pin number 8 via this resistor, 0 ohm resistor. So pin number 8. So pin number 8, this one is the pin number 8, is written EN underscore 1.2 VP. So you can check this voltage. Here supposed to come a 3 volt. So if you can't check here, then you can check here or here, because this point, all points are connected, okay. So you can check like this. Then if this voltage is not coming, then see why this is not coming, like that, okay. And what next? You can check, if you want to check the VTT voltage, that is half to the VDD, that is a 0.8 voltage. So pin number 20 VTT, when this VTT is coming, when it is giving enable to the S3 signal, this one SUSP, when the SUSP signal is coming to pin number 7, that is a 3 volt. If 3 volt is coming at pin number 7, that at pin number 20 you will get a 0.6 volt. So pin number 7 and pin number 20, pin number 7 this is the input, and pin number 20 is the output. You should get here 0.6 voltage, and input is coming 3 volt, but output is not coming here, then this chip is faulty. So in this way you can use this board viewer. So board viewer is very easy to use. So, and trace all the component, value of the each component, and location and connectivity of the all components. So it's very easy to trace out the motherboards.